Welcome back to the Deep Dive. Today, we're taking a really fascinating journey into the Erlang and Elixir ecosystem. Specifically, how a seemingly, low-level technical update in Erlang OTP 28 sent ripples, basically, all the way up to affect Elixir developers.
Yeah.
It's kind of a classic case, isn't it? Foundational change, creating this intriguing puzzle.
Absolutely.
And we're going to explore how the Elixir core team solved it with characteristic foresight and, well, elegance. Our source for this deep dive is a wonderfully practical piece. It's titled Elixir Regex Changes in OTP 28.
Right.
And it includes these great hands-on notes and observations from a developer who was, grappling with these exact issues while updating their CI pipeline.
Been there.
Yeah. So our goal today, unpack the specific impactful change, understand the strategy behind Elixir's response, which is really quite clever, and most importantly, what it means for your Elixir code going forward.
And that idea of ripples, it's so key. It really highlights why these foundational updates need our attention. Even changes that seem niche, they're incredibly important for stability, performance, and, the future evolution of the tools we use every day. They often create these intricate puzzles for developers and understanding not just the fix, but how they got there.
The process, yeah.
Exactly. The thought process, the trade-offs. It offers these invaluable lessons in, robust system design. It's really a masterclass in anticipating and managing that complexity.
Okay, so let's dive into the core of it then. We're talking about Erlang OTP 28.
Right.
For anyone maybe less familiar, Erlang OTP is essentially the backbone of Elixir, right? The underlying virtual machine, the framework.
All its libraries.
Yeah, exactly. That Elixir applications run on. And OTP 28 was a significant update to this platform. And kind of buried within it was this key change, a switch in its default regular expression or regex engine. The engine shifted from PRCE to PRCE2. Now, when we talk about a regex engine, we're basically talking about the component that handles pattern matching in text.
That's the one. It's how you find things, validate input, parse strings.
Right. And this isn't just like a minor version bump for some library.
No, not at all.
It's a fundamental change in how pattern matching actually gets executed deep down. And according to our source, this specific change, it initially went largely unnoticed.
Yeah.
Included by the author, until they started seeing some unexpected behavior during their CI updates.
Exactly. And it's not just a new name, PRCE to PRCE2. It's a shift from an older, very widely adopted standard to a newer, largely rewritten one.
Okay.
Think of PRCE Perl-compatible regular expressions. That's been the workhorse for ages, right? The familiar pattern language. PRCE2 is the modern successor. It's designed to address limitations, offer better Unicode support, often improve performance. But with a significant rewrite comes the potential for subtle behavioral differences. A regex pattern that worked perfectly fine under PRCE might just interpret an edge case differently, or even fail under PRCE2. And this potential for unforeseen incompatibility is what makes these foundational shifts tricky. It's not necessarily better or worse, just different in ways that can break assumptions baked into existing code.
Okay, so this foundational change in OTP 28, the shift to PRCE2, how did it actually show up in Elixir apps? Our source really pinpoints the key impact area. It was when regexes were defined as module attributes.
That's the trigger,
which is a pretty common pattern in Elixir, right?
Yeah.
For defining constants or configurations up front.
Very common.
So the problematic code looks something like this. You'd have a module, let's call it regexp.ends.maju.run.
Simple enough.
Yeah, seems straightforward. The hello regex is set as a module attribute at regex, and then used later in the run function. Now, the author of our source, they actually expected to see an argument error when running this on OTP 28.
Okay.
Based on some chatter they'd seen, especially around the earmark library, the markdown parser.
Right, I remember that discussion.
But here's where it kind of weird. When they actually tried to reproduce this argument error with Elixir 1.18.4,
it worked.
It just didn't happen. The code just ran, printed hello, no error, nothing.
Yeah.
It was that classic, works on my machine thing, leaving them scratching their head about the reported issues.
Okay, yeah, that's a fantastic illustration of a subtle but really critical problem. The question is why? Why would defining a regex as a module attribute suddenly become an issue with a new underlying engine?
Right.
Well, in Elixir, when you define something as a module attribute, especially a literal value like a regex,
Yeah.
that often gets evaluated and sort of baked in during the module's compilation phase.
During compilation. Okay.
So the Elixir compiler, maybe running on an older OTP version, compiles that relos using the old PRCE engine's assumptions, its internal structures. Now, fast forward. You deploy that compiled code onto a system running OTP 28.
Which has PRCE too.
Exactly. The runtime environment suddenly expects a different internal representation, or it might interpret bits of that precompiled regex differently.
Like speaking different dialects.
Kind of, yeah. It's like having, a perfectly good executable compiled for Windows XP and trying to run it directly on modern macOS.
Okay, gotcha.
The mismatch between what the compiler understood and what the new runtime expects can lead to, well, anything. Silent incorrect behavior or outright crashes like that argument error. The fact that our source couldn't reproduce it immediately, well, that points to something else going on, something clever.
And that something clever is exactly where the Elixir core team really stepped up. It shows their commitment to the developer experience, I think.
Definitely.
The aha moment, the reason our source author couldn't reproduce that argument error right away is that the Elixir core team had actually implemented a workaround in Elixir 1.18.4.
Proactive. Okay.
Totally proactive.
Yeah.
It was a very deliberate move to prevent a sudden, widespread breaking change from just, hitting developers overnight. It bought everyone time, crucial time.
That makes sense.
But they didn't just patch it and forget it. They introduced this really thoughtful, staged approach for future versions. So with Elixir 1.19, you'll now get a clear deprecation warning.
Okay, the next step.
Yeah. Our source shows the exact message, and it's super direct. Warning. Storing and reading regexes from module attributes is deprecated. Inline the regex inside the function definition instead.
Can't miss that.
No kidding. It's a vital heads up for any Elixir dev. And then, looking further ahead, with Elixir 2.0, that initial workaround, it's scheduled for complete removal.
The breaking change arrives.
Exactly. The old pattern just won't work anymore. But this staged rollout gives developers a clear map and plenty of time to refactor without being completely blindsided.
And the stage strategy, it's really, it's a testament to Elixir's commitment to its community. It's proper ecosystem stewardship.
Yeah, it feels very responsible.
It's a deliberate engineering choice, right? Balancing innovation with practical reality. They knew that platform updates are essential, but just dropping huge breaking changes without a clear migration path, that's incredibly costly and frustrating.
Oh yeah, nightmare fuel.
Right. So first, the workaround stabilizes things immediately. Then, the deprecation warning in the next release acts as this clear, polite nudge. Hey, you need to change this. And it gives you the how. Then scheduling the actual break for a major version, Elixir 2.0, provides this long runway for everyone, libraries, frameworks, apps to adapt gradually. It minimizes disruption, builds trust, and ensures Elixir evolves while prioritizing, developer sanity along with technical progress. It's just a great example of managing compatibility in this constantly changing software world.
So given all that context and this clear roadmap from the Elixir team, what's the official recommended way forward? The fix identified by our source. The advice is actually pretty straightforward. Cool. Define your regex within a function, not as a module attribute anymore.
Simple change.
Yeah, it's a simple structural change, but it completely future-proofs your code against these kinds of underlying engine shifts. Let's look at the corrected code example. It takes that previous snippet and turns it into this elixir.defmodule redo, def regex do, hello, def regex do. Def regex do, def regex do, re.run, def regex do, re.run.
Nice and clean.
Right. Instead of that regex, you now have a private function, regex0, that just returns your compiled regex. Then inside your run function, you just call regex to get it and use it. It's explicit, clean, and works perfectly with the updated environment.
And the beauty of this approach, the recommended way, lies in a key technical insight, something really valuable for you, the listener, to grasp.
Okay.
The source points out that with this method, the regex is compiled only on the first call, and the result is memoized by the beam for all future calls.
Memoized, so cached, basically.
Exactly, cached, which is brilliant. It hits two birds with one stone.
How so?
Well, first, you still get the performance benefit. That pattern isn't recompiled every single time you call the regex function.
Right.
The Erlang VM is super smart about this. It caches the result efficiently. But second, it completely resolves those compilation time issues we talked about.
Because it's compiled later.
Right. The regex is now compiled at runtime, but only the first time it's needed, using the currently active PRCE2 engine.
No mismatch.
No mismatch of expectations between compile time and runtime. It turns what could have been a performance issue or a breaking change into this elegant, efficient, robust solution that just works seamlessly with how the beam optimizes things. It's a really pragmatic and powerful pattern to adopt.
This whole deep dive, it's been about navigating these subtle shifts in a pretty complex stack.
Right.
And finding elegant solutions. And it turns out on this specific journey of discovery, our source author actually found an unexpected co-pilot.
Oh.
They explicitly mentioned that using AI significantly simplified the troubleshooting process for this exact regex issue.
Interesting. Okay.
Yeah, like it helped them figure it out faster.
Well, that raises a really important question, doesn't it? About the evolving role of AI in, well, modern development and just learning in general.
Definitely.
The author noted AI didn't just help them learn some new tricks about the beam itself, but it also accurately pinpointed specific changes in both the Elixir and the Erlang release notes that they'd actually missed when they looked manually.
Wow. Okay, that's quite helpful.
It really is. For you as a learner, this highlights a powerful new tool, right? AI can act as this intelligent assistant, sifting through what are often huge volumes of release notes, docs, commit histories.
Yeah, trying to find the needle in the haystack.
Exactly. It can help connect the dots between different pieces of information, highlight subtle dependencies, and just speed up your understanding when you hit some weird behavior. It's becoming less just about writing code and more about accelerating the understanding of the code and its whole complex environment, bridging that gap between tons of data and specific, actionable insights.
So what does this all mean for you, the Elixir developer listening in? Well, we've covered quite a bit of ground today.
We have.
It started with that underlying regex engine change deep down in Erlang OTP 28, a foundational shift. We then saw its very specific impact on Elixir, how it affected regexes defined as module attributes. We explored the Elixir core team's really incredibly thoughtful and staged solution. First, that workaround.
Buying time.
Then the clear deprecation warning.
The heads up.
And finally, that scheduled breaking change in Elixir 2.0.
The roadmap.
Exactly. And ultimately, we landed on the practical recommended fix. Defining your regexes inside functions to leverage the beam's smart memoization. This whole deep dive really underscores the value, I think, of staying informed about these subtle but critical shifts in the tools you rely on.
Absolutely.
And how understanding the why behind deprecations doesn't just stop your code from breaking. It actually makes you a more resilient, more effective developer.
Indeed. And, changes in these foundational software components, they're just inevitable. They're going to happen.
Yeah.
And the critical role that thoughtful transitions like Elixir's workaround and that multi-stage deprecation play and keeping the ecosystem healthy and productive, well, it just can't be overstated. It protects developers, ensures progress continues. So the provocative thought I'd maybe leave you with is this. How can we, as developers, as learners, not just adapt to these inevitable changes, but maybe even anticipate them more effectively?
Good question.
And how can we strategically leverage new tools, like AI, as our source author did, use them to cut through the noise, identify those crucial details, and turn potential roadblocks into actual opportunities for deeper understanding of the systems we build with and build upon? It's a crucial question, I think, as the whole software landscape just keeps evolving so dynamically.